may be old, but I'm still flexible.
At least for a day or two. Come next week, we'll be able to do that.
You know, my wife wants me to drive to Colorado the day after the marathon, come up there and be with her and the kids. I'm like, I'll fly the airplane, but she said, that's too expensive. We run this straight, there's no twist. Oh yeah, we can take another belt lacing length out of it. So we'll take the belt lace that's on it, and then we'll take one more width. I don't know that. I don't think that's a rubber, is it?
Hey, is this fabric?
Or a canvas type of material.
Got some sort of rubber. Well, maybe it's just war. Feels like rubber. Feel this.
Now, back in the day, Clipper there were several different companies that were making belt lacing equipment. Clipper was the biggest one. These are both Clipper. This is a Clipper lacer, and this is a Clipper guillotine. And so, let's take the bad side, or the one that was old. We took a 1/2 inch off of this before the show, and this time we're going to take that plus another length, about the length of those laces. Alrighty. Everybody like that?
Don't take too
Hey,
much.
it's got plenty of stretch.
Don't take too much.
Lovely. Square, straight. We are set. Now, pull the pin. Now, this belt lacing, we have multiple different sizes. The most common is number 3 lacing. Every box of belt lacing, this is from about probably 1940, 1950. I've got boxes back to 1910. But this is catgut. This is what they use to connect the pieces together. And because basically all you have is metal on metal. And this catgut slides between them, and it's very stiff. Okay, so now we need to cut off a small piece of this belt lacing, about the width of our belt, and then we will insert that into the belt lacer. Whatever type of machine they had that put these pieces of steel together was pretty fascinating. It would have been a great machine to be on. What's that? Nat Geo channel? Wonders, Mechanical Wonders, Mechanical Marvels. All right, now we take the belt lacing, we put it into the grooves on the lacer, run this piece of wire in there which holds it into the belt lacing machine. And then we have to remove the paper from the belt lacing material, and it is very sharp. Sooner or later, you're going to bleed when you're working with this equipment. All right, so once we get that out, I know everybody wants to reach in here and help me. Feel free. All right, now we come over the top with this and fit this belt right in there, so where your teeth are right where you want them. You like that, Will?
Yep.
You like that, Emily?
Mm-hmm.
All right, and then it has a self-tensioning function. Get it up kind of tight. All right, Emily, if you'll pull that side, I'll pull this side down. All right, back up, and we'll get it one more round tighter. Thank you, Will. All right, and go ahead. All right, back up. And we'll slowly apply the pressure. There's, now she's clicking. The power of compounding, is that what this is, Mr. Engineers and Mr. and Mrs. Engineers? I think that's probably plenty tight. And then pull our pin, and then out she comes, and we have a perfectly laced piece of belt. And we can use the entire width of this belt lacer, so we can lace up to 4 inches, actually 6 inches of belt with this lacer. They make bigger ones on stands to do threshing machine belts and so forth, but they had to have a tool for every activity that you would do out in the field, because there was no running into town to get you some new parts or get your parts fixed. All right, let's go lace her up. Where is your piece of catgut?
Oh, what do you?
Or what do you? Is a piece of metal that you got
just
for
a
this?
piece of metal in that one.
All right. You got steam yet?
Oh. Right on. 209. Yeah. About to lift off.
Still about 22 degree differential.
Yep. Wait.
Something. I think your throttle is leaking, isn't it?
Yeah, it leaks pretty
I
good.
can hear it.
Well,
I can hear it dribbling
I hear
in
it
the-
bubbling in there.
in the smoke box.
Oh well, the blower valve leaks.
Oh,
that's
what
what
it
you're
is.
hearing right
Yep.
now. Later, when I open that main dome, you'll hear the throttle leak by.
So when you were on a 30 to 45 day thrashing run out in the field with your steam engine, thrashing machine, water wagon, you had to be able to initiate and perform field repairs as we are doing right here.
Hey, how's it going, man? Pretty good.
And we're just gonna feed this belt back around the crankshaft, where there's a pulley that's mounted on the crankshaft, and this belt will go up and operate the governor. Let me have some, Will. Come over the top here. We may have to feed it up over the edge.
Yep.
Or maybe not. All right, you got the pin?
Yep.
Yeah, that is just about right. Okay, which side do you want to come from?
Whichever I can come to the
Okay.
inside.
Come around here.
That all?
Yep. Go ahead and push her in just a little. And now, with a nice tight governor belt, your governor is extremely responsive to any changes in speed, which is precipitated by any change in load. When we're on the sawmill here shortly, this governor spins at 380 RPMs. That's where it runs at nominal speed. The crankshaft flywheel is going to run at 275 RPMs, and we'll be running the sawmill blade. It's a 56-inch sawmill blade. Will be running at 550 RPMs. So the algebra to bring this governor to the correct speed brings it to 380 RPM. So even the slightest reduction in RPM at the flywheel due to a load placed on it by the sawmill generates an exponential change at the governor, which opens the valve and releases more live steam into the cylinder, providing more power when you need it. So it's a very efficient mechanism, the steam throttling governor, and it was designed in the late 1800s. Another device that was far ahead of its time. All right,
you
Will,
have it.
it's 9 o'clock.